Hello, everyone. Hello, everyone. Good evening, all. Today, we are going to start a revision session today, and that contains the discussion of carbonyl compound, which contains obviously aldehyde ketone, carboxylic acid, and then electrochemistry. Okay. So, friends, this class is like a bit different. The class that we have already done, like the offline class that we have already taken, this class is a bit different from the others class, right? Because today in this session, we are going to discuss not the whole chapter that we have, but we are going to discuss the important points, which is obviously important for your board exam, um, and then for JE also, right? So basically, we are not going to discuss the whole chapter today, but only the important topics, like what all portions are important in this particular chapter for your board exam and then for JE exam. Okay, so today, let's uh, start the discussion today with aldehyde and ketone. Okay, aldehyde and ketone. So, since we have already uh, discussed the whole chapter once, okay, so let me start with this aldehyde and ketone. The first thing, aldehyde and ketone. Okay, so as I said, that we are going to discuss today about carbonyl compound first. Okay, so carbonyl compound are generally those compounds which contains C double bond O group in the which has C double bond O group present there, right? Like suppose if I write this particular compound C double bond O and this bond here. Okay, so whenever we have this group present, so that comes under carbonyl compound that we know all these things, right? So if I write down C double bond O, both side if I attach R, this gives you what? Ketone, basic thing. And if I write down hydrogen one side, RC double bond O, H, this becomes aldehyde. Okay, acid is this RC double bond O, OH. Okay, this one is carboxylic acid. Carboxylic acid. Okay, so if we talk about aldehyde and ketone first, okay, for aldehyde and ketone, if I ask the reactivity of this, since we are going to discuss the important topic in this, okay, so we are directly going to discuss first reactivity into this. Okay, you see, the important thing that you have to understand here, the first thing, and on that only all the reactions of this chapter are based, and that is what? That is the polarity of C double bond O bond. Okay, in carbonyl compound, this bond is polar, right? If I write down here any, if it is aldehyde or ketone, whatever it is, but this carbon and oxygen bond is polar. Okay, and since oxygen is more electronegative, right? So obviously the bond pair of electron over here is shifted towards the more electronegative element or atom, that is oxygen. So we'll write here partial negative charge on it, and the carbon contains partial positive charge on it. Okay, so any nucleophile, if you have, the nucleophile has tendency to attack onto this carbon atom, and that's how the reaction proceeds of various carbonyl compound. Okay, so the point here is what, that if I talk about the reactivity of this compound, okay, since the reaction takes place because of the positive charge present onto the carbon atom here. Okay, so if this, the charge density of this carbon, or the positive charge density of this carbon is more, it means the attack of nucleophile is easier. Okay, so if I talk about the reactivity of aldehyde and ketone, right? So C double bond O and C double bond O, H this side, R here, and R here. Okay, you see both alkyl group, or we know this alkyl groups are what? Alkyl groups are uh, shows plus I nature. So here also we have electron releasing tendency, electron releasing tendency. Okay, so this alkyl also has electron releasing tendency. This one is ketone, and the second one we have taken, that is aldehyde. Okay, so if I ask you, like in which of these compounds, whether it is aldehyde or ketone, the positive charge density on carbon atom is more, right? Obviously, the answer will be what? The answer will be aldehyde, because you see, in aldehyde we have only one alkyl group present, but in ketone we have two alkyl group present. Okay, so since what we say, since the positive charge density on carbonyl carbon is more than is more in case of aldehyde, and why it is more? Because it has only one alkyl group present. Okay, so it's more in case of aldehyde, hence the reactivity of aldehyde is more to that of ketone. More to that of ketone. Okay, so first thing that we have concluded today is the reactivity of aldehyde is more than to the reactivity of ketone. Okay, now this thing we have also done in the class, right? So aldehyde ketone reactivity we have already compared. Now if I ask you one additional thing over here, that if we compare the reactivity of aromatic aldehyde and aliphatic aldehyde, then what happens? Okay, reactivity of aromatic aldehyde and aliphatic aldehyde. Okay, you see, now we are going to compare the next thing, that is reactivity of aromatic and aliphatic aldehyde. Aliphatic aldehyde. Okay, so which one is having more reactivity in this? Okay, again in this case we again see the positive charge density on the carbonyl carbon. Okay, So you see, if I talk about the aromatic aldehyde, and suppose if I take this benzaldehyde over here, C double bond O H, and any aromatic aldehyde, suppose CH3, C double bond O and H here. Okay, so what happens in aromatic aldehyde? In aromatic aldehydes, or even for ketone also, like whatever we are discussing over here, it is true for ketone also, right? The aromatic aldehyde and ketones are generally less reactive than the corresponding aliphatic aldehyde or ketone. Okay, so aromatic aldehyde and or ketone, right? Aldehyde or ketone, whatever it is less reactive, and this one is more reactive. More reactive. Why it is less reactive? Any aromatic compounds are less reactive. Why it is less reactive? Because of resonance. Okay, you see, this can form the resonating structure over here. So because of this delocalization of electron, the positive charge density on this carbon atom decreases. Okay, that's why its reactivity decreases. So all these things are true for, we have taken the example of aldehyde, but this is true for ketone also. True for ketone, right? So basically, like, to sum up all this, generally aldehyde are more reactive than ketone. If you are comparing aliphatic and aromatic aldehyde, then aliphatic aldehyde are more reactive than aromatic aldehyde, and this thing is also true for ketone also. Okay, so this is it for the discussion of aldehyde. If I give you one simple order into this, sometimes it is important for exam. Okay, and that order is this: if you talk about the aromatic the reactivity order of this, the most reactive uh, compound we have in this carbonyl compound, and that is, if you write down first, reactivity order. Reactivity order. Okay, the most reactive compound we have, that is RCHO. Okay, and then if you compare aldehyde and ketone, so obviously aldehyde are more reactive than ketone, and in aldehyde also we know aliphatic aldehyde are more reactive than aromatic aldehyde. Then we have ketone, and in that we'll write first aliphatic ketone, and then we have aromatic ketone. Okay, aliphatic ketone and aromatic ketone. Then we have acyl halide, acid halide, or we can write down the further reactivity order also. But this is it important we have till here, aromatic ketone. Okay, so this is what the reactivity order we have. Okay, now if we talk about various reactions, okay, that we have done the preparation method of aldehyde and ketone, okay, that we also have done in the class, the offline class, so we can you can go through to that your notes and you can understand. Okay, so, and since it is a revision class, so we are going to discuss only the important or the most important topic which you should not forget or leave as far as this JEE and board exam is concerned. Okay, so the most important reaction in this chapter we have, and that is condensation reaction. Condensation reaction. Okay, and in this condensation reaction, the first reaction we are going to see, that is aldol condensation. Aldol condensation. Okay, here we are going to discuss two reaction, that is aldol condensation and Cannizzaro reaction. Okay, aldol and Cannizzaro. So as far as this exam is concerned, whether it is board or JEE, okay, if you see the previous year questions, okay, from this chapter, 90%, 85 to 90% of the time, they have asked about this particular reaction, aldol condensation or Cannizzaro, both. Okay, so this reaction is very important reaction we have. Okay, if you have suppose last 10-15 minutes and you have to revise aldehyde and ketone, then I would suggest you to go through this reaction the last 10-15 minutes. Okay, so that is how like this reaction is. Okay, now coming back to this reaction is what this reaction takes place because of alpha hydrogen. Okay, reaction due to alpha hydrogen. Aldehyde or ketone must have alpha hydrogen present into it. Okay, aldehyde and ketone must have alpha hydrogen to it. There are few exceptions also we have in this. Okay, that we'll see later on. Okay, but the necessary condition is alpha hydrogen is must required into this. Okay, why this reaction takes place? You see this first. Suppose if I take the example of acetone. Okay, acetone is CH3, C double bond O, and CH3. Suppose if I write like this. Okay, now this hydrogen and this hydrogen are acidic hydrogen. Okay, any hydrogen which is adjacent to this carbonyl group, okay, these are acidic hydrogen. Okay, and since it is at alpha position, this is alpha hydrogen, and these are also alpha hydrogen. So if I ask you how many alpha hydrogen present in this, the answer will be 6 alpha hydrogen present. Okay, now the thing is that this reaction takes place in both medium. Okay, basic medium or base catalyzed, base or acid catalyzed reaction. Okay, the meaning of this is what this reaction takes place in presence of base also or in presence of acid also. Okay, now next thing is what, suppose I am taking this particular compound. Okay, and this is reacting in basic medium, suppose OH minus I am taking. Okay, and in fact we cannot take one molecule of this, but we should take two molecules of it. Okay, every for this aldol condensation reactions we take two molecules of one particular aldehyde or ketone. Okay, so OH minus you have, it is the base, right? And this base can easily takes this acidic hydrogen from this position, okay, alpha position. So when this OH minus takes this hydrogen, okay, so what it forms, H2O comes out and it forms CH3, CH3, C double bond O, CH2, negative charge on it. Okay, now the important thing here is it is what this aldehyde or ketone, whatever it is, can easily lose this H plus ion. The reason behind this is what, because this ion that it forms, it is the conjugate base of it. Okay, this is the conjugate base because it loses H plus ion, conjugate base of this compound, okay, acetone. So when this compound forms, this compounds are what, this compounds are resonance stabilized. Okay, you see, you can draw the resonating structure of this compound. That is what it is, CH3 CO minus double bond CH2, double bond CH2. So this is what, because of this resonating structure, that this conjugate base or anion, this anion is stabilized. That's why it can easily lose H plus ion from here. Okay, so that is how the reaction starts. Okay, now you see, when this we have negative charge on it, so this negative charge, okay, this negative charge attacks on the other molecule. Like suppose if I write this particular compound here like this, CH3, C double bond O, CH2, negative charge on it, plus we have one more molecule of this, that is CH3, C double bond O, CH3. Okay, and then what happens? This negative charge. Okay, this where is the negative? This negative charge. This negative charge attacks onto this carbon atom. Okay, obviously this um, carbon and this carbon joins here, right? So what we can write here, you see, we can write CH3, this CH3, this carbon, and this carbon are joining. Okay, so basically we can write here CH3, CH, CH3. Okay, so we can do this. Just let me erase this first. Or suppose we'll take the another page only. Okay, let me drop this. Okay, now you see, we can take any other example also. Okay, so why this H plus it is losing, that we can easily understand because of that resonating structure, that conjugate base that you have, that is resonance stabilized. Okay, now you see, suppose we'll take aldehyde first. Okay, right, because aldehyde are more reactive. So we can take this CS3, C double bond O and H. C double bond O and H, right? So what happens here? This CH3, CHO, and we are taking 2 moles of this, like as I said, and we have OH minus here. OH minus, basic medium reaction I'm talking about. Okay. Now in this one, the first compound that we get here is what? CH3, CHOH, CHOH, then CH2, CHO. This is the first compound we get. Okay, this we call it as what? Alpha. This is alpha position, this is beta position. Okay, so this we call it as, this is alpha and this is beta. Okay, so we call it as beta hydroxy aldehyde, since we are taking aldehyde as the reactant into it. If you take ketone, then it becomes beta hydroxy ketone. Okay, so this beta hydroxy ketone, we also call it as ketol. Okay, and if you take aldehyde here, so we call it as aldol. Okay, if you take ketone here, it becomes ketol. Okay, so ketone gives you ketol, aldehyde gives you aldol. Okay, so after this, when you heat this, then condensation takes place. And how condensation takes place? This hydrogen and this H comes together and forms H2O, and the final product is this CH3CH double bond CHO. Okay, this is the final product we have in this aldol condensation. Now if you see the mechanism of this, the final product will get this. But if you see the mechanism in this is what? Suppose uh, we have one molecule CH3 C double bond O H here, and this is the basic medium reaction. So OH minus, this OH minus takes this H and it forms CH3 C double bond O, right? And H2O comes out. Okay, and this oxygen will have what? This carbon will have negative charge on it. Okay, this carbon will have negative charge. Yeah, it says the negative charge plus H2, right? One mistake I made. Okay, this bond, this OH minus will take alpha hydrogen. No? Let me correct it. Okay, we have OH minus here. Okay, so now you see this OH minus will take one hydrogen from this. This alpha hydrogen takes part in the reaction. No? So this OH minus attacks onto this carbon hydrogen atom. Okay, H2O comes out and we get CH2 negative here. Okay, CH2 negative, and this hydrogen will be as it is. Now this molecule which is CH double bond O in the first step, and here we have CH2 negative, and one more molecule of this, since we are taking 2 mole of it. Okay, so one more molecule we have CH3 C double bond O and H. Okay, CH3 C double bond O and H. Now this negative charge attacks onto this carbon atom because it is partial positive charge, and this pi electron goes here. So this carbon and this carbon joins. Okay, so what we can write, CH2 C O minus H. Here we have CH3, and here we have CH double bond O. Okay, what we have to form? CHOH, right? We have to form CHOH. This negative charge, that O minus we have in presence of H2O. Okay, now we have H2O here. So this takes this H plus here and it forms CHO, CH2, CHOH, and then we have CH3, CH3, right? This is, you see, alpha and beta position. This is nothing but this product we have, beta hydroxyaldehyde. Okay, this product. Now when you heat this H and OH comes out, and the final product will be CH3 CH double bond CH and CH. Remember one thing, that if you do not heat this reaction over here, if you do not heat, then this product won't form. H2O won't come out into this. Okay, we'll end up with beta hydroxy aldehyde or ketone according to our reaction. Okay, so this is how the reaction proceeds into this. Okay, this reaction also takes place in um, this reaction also takes place in um, acidic medium also. So let me write down the mechanism of that acidic medium reaction, how it reaction takes place in acidic medium. You see, if we have acid medium reaction, why I am discussing all this mechanism again? Because we'll see after this, we'll see some questions which has been asked in JE exam. So this reactions and mechanism are very important. Okay, so you see, if you are taking some suppose we'll take now ketone, right? So if you have, suppose, CH3 C double bond O and CH3. Okay, so we are taking 2 molecules of this, so this one is the first molecule we have. Okay, the reaction itself says we have to take 2 molecules of this, so first molecule of it. Okay, now suppose the acid we are taking, which is, suppose, H plus, which is, suppose, HCl. Okay, so what happens in this, since this oxygen has 2 lone pair of electron on it, okay, this lone pair of electron attacks onto this hydrogen atom and Cl minus comes out. So this reaction goes like this: CH3 C double bond OH, positive charge on it, and then CH3. This is the first step reaction. Now this Cl minus from this takes one of the hydrogen atom from here. So if I write the hydrogen atom like this Cl minus takes this hydrogen atom and will get negative charge onto this carbon. Okay, so that we can write what? CH3 C double bond OH plus single bond CH2 negative. Now this negative charge attacks onto the another molecule. So let me write down this first. CH3C double bond OH plus CH2 negative plus CH3 C double bond O CH3. So this CH3 C double bond O CH3 is what? It is the second molecule. We are taking two molecules for this. Okay, so what happens? This negative charge attack onto this carbon atom. Okay, and one more thing, you can see this all these molecule you are taking, all these molecules are protonated now. This takes this H plus, forms this, so this also takes H plus and forms this. You can write down this also here, positive charge here, right? Second molecule which is also protonated. Okay, now this negative charge, this attacks on what? The carbonyl carbon, because carbonyl carbon is partial positive charge having, right? So this negative charge attacks onto this carbon atom and it forms what? It forms this CH3 C double bond OH plus, then we have CH2 C CH3 CH3, and here we have this OH, right? When this bond goes over here, when this attacks, so it forms OH on this. Okay, forms OH on this. Now again, what happens? Proton from this oxygen, because this oxygen is what? It is electronegative, less stable. This H plus comes out and comes onto this oxygen atom. This H plus comes onto this oxygen atom. So we can write down this as CH3 C double bond O CH2 C CH3 CH3, and here we have OH2 plus. Okay, and finally what happens? This OH2 comes out, right? H2O comes out, and this hydrogen, one of this hydrogen also comes out as with chlorine. So if I write down this Cl minus here, right, and minus H2, how this minus H2O goes? You see, if I write down this hydrogen here like this H2O comes out from this, and this Cl minus takes this H plus from here, and this bond pair comes over here. So if I write down the final product here, that will be CH3 C double bond O CH double bond C CH3 CH3 plus H2O comes out into this, and HCl also comes out into this, HCl. Okay, so this is what the product we have over here, right? This is what the product we have over here. So basically, if you write down the product directly from this reaction, you see CH3 C double bond O CH3, CH3 C double bond O CH, two hydrogen comes out from here, and this attached with the double bond of this carbon atom over here. So directly we can write down the product. Okay, so if you see the one single step product into this, okay, the one single step product, if I write down, then the product will be this one. If you want, you can copy it down. Okay, I'll move on. Okay, now you see, how do we write down the product in one single step? Okay, mechanism I have explained you. Now suppose if you have this, the same example I am taking so that you can understand easily. CH3 C double bond O CH3 plus one more molecule we have O double bond C, CH3, CH3, and this reaction takes place in H plus. Okay, so what happens? This from this carbon, you take H2 out, and this oxygen forms H2O. Okay, so basically this carbon and this carbon you have to join with double bond. So the product here will be CH3, C double bond O, CH2 hydrogen comes out, one hydrogen left, double bond C, and this has two methyl group CH3, CH3 here. Okay, plus H2. This is what the product we get into this. So like this, you can write down the product in one single step. Okay. Now, now here you see the one important um, point here, that is the number of product that we obtain. Okay, so you see we are taking this the two reaction that we have done just now. Here we have taken the same aldehyde or ketone. Okay, we have taken what? The same aldehyde or ketone. But this aldehyde or ketone, the two molecules that you are taking, it may be same or may not be same. Okay, or we can have one aldehyde and one ketone also. Like if you see, if you are taking this reaction, if you're taking this reaction CH3 CHO plus one aldehyde we are taking, and another one is ketone CH3 C double bond O CH3. Okay, now this kind of reaction we call it as cross aldol condensation reaction. Okay, so when you have suppose one aldehyde and one ketone. Okay, or if you have aldehyde plus aldehyde, or you have ketone plus ketone. Okay, in this both are different. Both are different means suppose one these two aldehyde are different from each other, these two ketones are different from each other. So when different aldehyde we are taking or different ketone we are taking, or one aldehyde and one ketone we are taking, so this kind of reaction we call it as cross aldol condensation reaction. Cross aldol condensation reaction. If we have two two same aldehyde, if here like we have done the previous two example, two same aldehyde or ketone we are using, then we call it as self condensation reaction. Self condensation reaction. Okay, two same aldehyde or ketone if you have, so we call it as self condensation reaction. Okay, so now the here you see, on the basis of this we can find out the number of product that is formed. Okay, so if I write down the first reaction, like suppose CH3 CH double bond O plus CH2 H C double bond O CH3. Okay, so what happens in this? This hydrogen comes over here, and the product if I write CH3 CH OH CH2 C double bond O CH3. Okay, this is what the product we have if we do not heat this. Okay, the product is this, and this kind of reaction, since we have one aldehyde and one ketone, so we are calling it as cross aldol. Cross condensation. Cross aldol condensation or cross condensation reaction. Okay. Now, the second example, if we have, in this also, one more possibilities are there. I am taking the alpha hydrogen of ketone here, right? This alpha hydrogen is taking part in the reaction. So we can take alpha hydrogen of aldehyde also. Okay. So what happens if you take alpha hydrogen of aldehyde? You see this, the second possibility. C double bond O H CH2H plus, here we have CH3 C double bond O and CH3. So what happens in this? You see, this hydrogen joins with this oxygen, and this carbon joins. Okay, so this carbon has two CH3. So I can write down the product into this. The product here it is. This carbon and this carbon joins. Okay, so we'll write CH2 C CH3 CH3 OH, and this we have CHO double bond O. Okay, so with this two reactant, we have two product possible. Cross condensation also, when alpha hydrogen of ketone takes part in the reaction, and then when alpha hydrogen of aldehyde takes part in the reaction. Okay, now that these two reactions are what? These two reactions are cross condensation reaction. Okay, this is also cross condensation reaction, and this one is also cross condensation reaction. Now the second possibility we have in this, that is self condensation. We are taking sufficient aldehyde, so we can have self condensation also. So in self condensation, you see what product we may get. Okay, so suppose we have two aldehyde only, that is CH3 C double bond O H plus CH2 H C double bond OH. This hydrogen comes onto this oxygen, and we get CH3 CHOH and then CH2 CH. In this only, the second possibility, this is for aldehyde, we are taking off for ketone also we can do. CH2 C double bond O CH2H plus CH2 C double bond O CH3. Sorry, here also we have 3. Okay, so this hydrogen and this oxygen joins, and this carbon and this carbon joins. So the product here is CH3 C double bond O CH2 COH CH3 and CH3 here. This both reaction, we are calling it as self condensation. Self condensation. Okay, why it is self condensation? Because the same molecules are reacting. Okay, same molecules of aldehyde and ketone are reacting. Okay, so now in this, if I ask you, like suppose this product is A, this product is A, this product is B. Okay, if you take CH3CHO, self condensation, this product is C and this product is D. So all these four reactions are possible into this. Okay, we can have cross condensation also, we can have self condensation also. Both condensation are possible. Okay, so the percentage of formation follows this order. the percentage of A is maximum over here, right? Then the percentage of C we have, and then the percentage of B we have, and in the last, the percentage of D we have. Why we are getting this order? Can you think on this, or can you explain this? Why we are getting this particular order? A greater than C, greater than B, greater than D. The simple reason is that first of all, that we already know that the aldehyde are more reactive than ketone. Okay, so obviously when the ketones are taking part in the reaction, this is less reactive. So obviously the percentage of D will be less over here. Okay, now